Good day to all of you, ladies and gentlemen. Thank you for joining me for this lecture. My name is Tomasz Kaczmarczyk and I'm Sales Manager in SECO WARWICK's Aluminum Process and Cap Furnaces team. Today I will share with you our knowledge about safe magnesium alloys heat treatment. I would like to tell you how SECO WARWICK studied the recommendations, made own research and found a fault in the AMS 2768C norm. At the beginning, I would like to present you a short agenda of today's meeting. I will start with a request from quote from one of our customers for magnesium alloys heat treatment. Then I will describe the disadvantages of sulfur usage for oxygen removal from the furnace during magnesium alloys heating process. Our research and study of world standards for magnesium alloy heat treatment, CO2 selection to remove oxygen from the furnace. Then I will also explain how to avoid a fire in the furnace and tell you how we found critical error in AMS 2768C norm. On this particular example, you will see SECO WARWICK's research and development of process safety, control system design, and request for quote final result in the form of a delivered and installed furnace. In 2014, SECO WARWICK was requested to quote the line for solution heat treatment and aging of magnesium parts for aviation industry. The subject of the inquiry was magnesium alloy series ML5 and ML10. The customer needed an equipment for T4 and T6 processes at 420 and 540 degrees centigrade, respectively. After an initial specification analysis, a draw bottom furnace was selected. But with so far unknown to us magnesium alloys, additional questions arose. In industrial conditions, heat treatment of magnesium alloys is associated with the risk of explosion. Under the influence of temperature and presence of oxygen, easily flammable mixture is formed. Clean magnesium starts to burn at a temperature of 760 degrees and magnesium powder even at a temperature about 470 C. However, our experience shows that magnesium alloy can start burn at lower temperatures. This movie shows you how the chemical reaction of magnesium ignition occurs under mentioned conditions. The presence of high temperature and oxygen. The challenge of this project was to get rid of the oxygen from the furnace atmosphere in a safe and ecological manner. Our lab tests have shown that the lowest ignition temperature of the ML5 magnesium sample is 492 degrees centigrade. While lab tests with a sample of the ML10 alloy showed that the lowest ignition temperature for this alloy was 608 degrees centigrade. So it is much more lower than the figure of 760 degrees C given in the sources. First idea was to use sulfur for this purpose, because such solution was used by the customer at that time. It was one of the recommended also by international standards. The customer dosed the sulfur in the furnace in a very simple way. A bucket filled up with sulfur was placed in a heating chamber. Under the influence of temperature, sulfur combustion and induction of oxygen took place. One of the drawbacks of such system was the lack of control over the amount of sulfur. Therefore, at the preliminary stage of the project, we designed and wanted to use a continuous sulfur dosing system. We made our own tests with sulfur using our lab furnace. On the slide you can see the system used by the client on the left and our design on the right. In the next stage of the design, we discovered that the use of sulfur has serious consequences. Smelly sulfur dioxide is produced during the sulfur combustion reaction. Additionally, under the influence of moisture, highly poisonous and corrosive sulfuric acid is formed, which poses a serious threat to health, environment and device itself. On the sample photos you can see acid damage and sulfur deposit in the furnace. Moreover, sulfur use wasn't compliant with European regulations. Therefore, it became obvious for us that we had to quit using the sulfur and find different and safe ingredient. On our own, we started international research for safe magnesium alloys heat treatment information or recommendation in various reputable sources. We have exchanged knowledge with Polish Institute of Non-Ferrous Metals in Skawina and Gliwice, National Fire Protection Association, and one Russian Science and Research Center. We analyzed the data for magnesium alloys listed in the norm AMS 2768C, as you can see on the slide, as well as ML5 and ML10, which are not even mentioned there. As a result of our research, many other gases were consequently excluded. And finally, we found proper purging gas that was a very good substitute for sulfur. This component was carbon dioxide, economical and ecological gas. When the furnace atmosphere oxygen level is reduced by purging with carbon dioxide, there is no risk of magnesium ignition under the safe temperature. However, when magnesium starts to burn and reaches the temperature above 750 C, the reaction of carbon dioxide decomposition starts as well. Carbon dioxide decomposes into organic compounds, molecular oxygen, and atomic carbon. Both are escalating the fire. During the process, special attention should be paid to the amount of the dosed carbon dioxide. Its measurement should be carried out continuously. Therefore, SECO WARWICK decided to use carbon dioxide analyzer with a suction pump to increase the dynamics of the measurement. Now a few words about the advantages of carbon dioxide. At a low concentration, it effectively reduces the O2 level in the furnace, protecting the load against oxidization. It is an expensive gas and occurs naturally in the Earth's atmosphere. At the concentration used in the furnace, when the door is opened, it dilutes quickly in the air, without creating a suffocating atmosphere. Nevertheless, just to be on the safe side, SECO WARWICK provided a sensor to warn against excessive CO2 concentration. As you already know, the ignition of magnesium powder takes place at temperature of 470 C. To prevent this, it's needed to use a fire extinguishing system in the furnace atmosphere. AMS 2768C norm referred to NFPA 480 standard, allowing the use of nitrogen in a furnace atmosphere to do that. We decided to check it out with our R&D department. As a result of these tests, we found that magnesium doesn't burn in cold nitrogen, but it burns very well in uncompressed form of room or ambient temperature nitrogen, the same way as oxygen does. This surprised us and brought into question the recommendations of magnesium heat treatment in the norm AMS 2768C. Okay, now let's try to compare the advantages and disadvantages of nitrogen and argon. Advantages in favor of using nitrogen are low price, the possibility of obtaining it from the air. It is a neutral gas for human health and does not react with many chemical elements. Nitrogen disadvantages are that it reacts chemically with magnesium at high temperature to form magnesium nitrate, which must be disposed of. Because it can be form poisonous. After our research, studies and lab tests, we found that AMS 2768C norm refers to NFPA bulletin number 480, which recommend the use of nitrogen as the extinguishing agent for magnesium fire. However, the NFPA replaced bulletin 480 with 484, in which nitrogen is not allowed as an extinguishing agent. This is a very significant change that has a huge impact on the safety of process in many production plants around the world. Therefore, when we completed the investigation and summarized the results of our research, as the next step, we send them to SAE International and NFPA, recommending changes to AMS 2768C standard. We have reported a very serious fault with recommendation of nitrogen as an extinguishing gas for magnesium alloys heat treatment. We also noted that many of the devices in use should be redesigned for safety reasons. As a result of our intervention, SAE called a meeting to analyze our results. However, no corrective action was taken yet. AMS 2768C norm was reaffirmed in 2018, but unfortunately, SAE International did not decide to revise it, leaving in actual NFPA 480 standard. According to our information, SAE didn't want to take responsibility for such fault in the norm. They transferred responsibility to the NFPA, keeping the recommendations from the previous bulletin. Moreover, SECO WARWICK, in cooperation with customer and Russian university, developed the safe level of carbon dioxide in the furnace atmosphere for carrying out the process with magnesium alloys ML5 and ML10. This information is our know-how and confidential, but we can say that the safe level of carbon dioxide for these specific alloys is different than AMS recommendations for other magnesium alloys. As you already know, the heat treatment of magnesium alloys with carbon dioxide and argon requires an advanced process control system. Therefore, we designed such in order to watch over the operational safety. The argon extinguishing system is based on a programmable safety relay that works with a temperature controller. Two thermocouples are installed on opposite walls of the furnace in the axis of movement of the furnace door, and they are connected to the temperature controller. The controller switching value is sent from PLC after scanning the recipe of the current process, which is set point of heating segment with carbon dioxide. Exceeding the set point by 6 degrees turns off the furnace heating. When the temperature in the furnace increases further, set point plus 15 degrees, despite of turned off heating, the argon flow is activated, while carbon dioxide flow is cut off. We have reached the end of this lecture dedicated to revealing the secrets of safe heat treatment of magnesium alloys, and the time has come to summarize it. As you could see in this particular case, SECO WARWICK has extensive intellectual resources in the form of its own R&D department and highly skilled personnel. Our resources are additionally enriched by close and constant cooperation with research and science centers around the world. By expanding our knowledge and searching for answers, even those obvious ones, we find innovative solutions. Like in this particular case, we set the new trends in non-ferrous metals heat treatment solutions. We always take care about the customer satisfaction and provide dedicated solutions tailored for their needs. Thank you for participation and have a good day. Bye bye.